Hello guys, this is the Med Dude and today we're doing Edexcel P2, October 2021. So let's get right to it. So this is question number 1. The first three terms in ascending powers of x of the binomial expansion of 1 plus kx to the power 16 are 1 minus 4x plus px squared, where k and p are constants. Find in simplest form the value of k and the value of p. So we have to expand the brackets, right? So we have to binomially expand this. So this will look like, so this would be 1 plus kx to the power of 16. So this would be 1 to the power 16 plus 16c1. And then we take 1 away from the power. So multiplied by 1 to the power of 15 multiplied by the x, which is kx. Okay, same thing, we can move on. So the plus 16c2, this is the third term, right? The value of k and p, we can find that out using this. And this would be 1 to the power of 14, 16 take away 2, and this would be squared. Okay, so when we expand this, what do we get? We get 1 plus 16c1 is just 16 times by 1, which is just 1. Times by kx, so that would be 16kx. Okay, so on 16c2, which is, so what's 16c2 in the calculator, we will get 120. 120 times 1 is just 120, and then times by, so when we expand this, we get, what do we get? We get k squared x squared. Okay, so we're left with 120 k squared x squared. Now, what is this equivalent to? You can see over here, 1 minus 4x and px squared. So we can just write them. So this is equivalent to 1, and it's minus 4x. So I'm just going to write minus 4x, and that is px squared. So that's just plus px squared. They want to find what k is. We can get that from this, our x term coefficients. You can see there's k and a number, so we can write 16, k equals negative 4, so k would equal negative 4 divided by 16, and when you simplify that, you can divide by 4 each side, from top and bottom you will get minus 1 over 4. So that is our answer for k. So k equals 1 over 4. That's part I. So now let's move on to part II. So how can we find the value of p? Now we can see there's only one term that links p and our initial term over here. So let's just write it down. So 120 k squared equals what? Equals our p. Do we know what k is? Yeah, we know what k is. See, we know what k is. So we can just substitute it. So 120 multiplied by, so what's k? K is minus 1 over 4, and then square it, so equals p. So what will it equal? So p equals 120 over 1 over 4 squared is 1 over 16. So divided by 16. So 120 divided by 16, when you put it in the calculator, we get 15 over 2. So you can either write it as p equals 7.5 or 15 over 2. Both are correct. That is the answer for part II. Now let's look at part B. So g of x equals, so we have 2 plus 16 over x multiplied by 1 plus kx to the power 16. Using the value of k in part A, so this value, find the term in x squared in the expansion of g of x. Okay, so how do we do that? So we know, right? What do we know? We know that this goes on, right? This goes on. So this goes on to something x plus something x squared plus something x cubed, right? It goes on. But we are only interested in the x squared term, right? So how can we get the x squared term? Either this multiplies by the x term, so either 2 multiplies by the x squared term, right? So this is one of the ways to get our x squared term. And you have the 16 over x. So 16 over x has to multiply by something that is x cubed to give us something that is x squared, right? Because this x cubed is now converted into x squared because one of the x's is cancelled out. This becomes a 2. So what do we need? What terms do we need? We need the terms x squared and x cubed from the expansion. Now, do we have the term x cubed in the expansion? We do not have the term yet for the x cubed. So what do we need? We just need, so let's just write down. So we have part B, we have 2 plus 16 over x multiplied by the expansion. So now let's expand the expansion. That's 1 minus 4x, right? Plus, now what's p? We know px squared is 7.5. So we can just write 15 over 2x squared. Now, do we know the cubed? We don't. But we can figure it out, right? We can figure it out because, so let's figure it out. So if we want to find out what the x cubed term is, what do we do? So we continue. So this was 16c2 here. So this would be what? This would be what? This would be 16c3, right? And then what? 1 to the power of 16 minus 3, which is 13, times by kx whole cubed. So that would be what? So that would be, so what is 16c3 in the calculator? So 16c3 is 560. So 560 multiplied by 1, which is just 1, multiplied by k cubed, x cubed. So this is, so now we're just multiplying. So 560 multiplied by minus 1 over 4 cubed. This gives us what? You can check. So 560 times by minus 1 over 4 whole cubed. So this gives us minus 35 over 4. So that's our x cubed term. So this we can now plug back in to our expansion. So this becomes minus 35 over 4 x cubed. That's all we write. That's all we need. And what are we interested in? 2 times 15 over 2x squared and 16 over x times minus 35 over 4x cubed. So let's just do that then. Let's do that. So that would be 2. So let me go 2 times what? 15 over 2. So 15 over 2x squared plus 16 over x multiplied by minus 35 over x cubed. Right? Okay. So 2 times 15 over 2 is just 15x squared. Plus, so 16 times minus 35 over 4. When put in a calculator, you get minus 140. Now is it x cubed? No, it's x squared because x cubed now becomes x squared because of this cancellation. So we're left with, so 15 minus 140 minus 125x squared. So what's the term? What did they ask? They want to find the term. So term, so x squared term in g of x expansion. Expansion is minus 125, minus 125x squared. So that is the answer. Now let's move on to question number 2. So we have a sequence is defined by the first term u equals 6 and the nth term un plus 1 equals k un plus 3. So find in terms of k for expression of u3. So that's pretty straightforward. So if u1 equals 6, right? So u1 plus 1, which is equal to u2 obviously, is k times the first term, which was 6 plus 3. So that's u2, right? So I'll just write a here. So we'll write what we did. So u1 equals 6. So u2 equals 6k plus 3. Now so u3 would be same thing. So k times u. So in this case it will be k times u2 plus 3 equals u3, the third term. So that would be k times 6k plus 3 plus 3. Should we expand it? We can expand it. So u3 would be 6k squared plus 3k plus 3. So the answer is this, and both of them are equally correct. Okay. Now let's move on to part B. Given that the sum from the terms 1 to 3 of this sequence is 117, find the value of k. Now, do we have the first 3 terms? Yes, we do. We have term 1, term 2, and term 3. So in this case, we can just add them all together. So u1 plus u2 plus the third term equals 117, and now we can just add them. So that would be 6 plus 6k plus 3 plus 6k squared plus 3k plus 3. So this was the third term, this was the second term, and this was the first term, equals 117. Let's collect like terms. So we only have 1 k squared, so that's a 6k squared. And then how many k terms do we have? So we have 6k and 3k. So we add them, we get plus 9k. And what are we left with? So we have 6 plus 3 is 9, 9 plus 3 is 12. So 12. This is plus 12 equals 117. Then we can take it to the other side. So now it's just a simple quadratic equation. So plus 9k minus 12 minus 117 is minus 105 equals 0. Now can we simplify this? Pretty sure you can. We can divide by 3. So when you divide by 3, we get what? What do we get? We get 6 divided by 3 is 2. 9 divided by 3 is 3. And 105 divided by 3 is 35 equals 0. Now can we factorize this? I think we can. Let's see if we can. So we have 2k on this side, and then we have k on this side, equals 0. You can actually put in the calculator from here as well, but let's see if we can factorize. We get the same answer. So we need two numbers that add to get 3k, and when you multiply them, gets 35. They're both positive, so this should be, let's see, so we have 7 and 5, so let's say this is 7, this would be, so when we multiply them, you get minus 14, this is plus 5, no, that doesn't work. So let's try plus 5. What if we try plus 5 here? That'd be 10 minus 7. So does that check out? So 10k minus 7k gives us 3k. So that works out. So this in fact is the right factorization. So from this, let's work out our k values. So we have either 2k minus 7 equals 0. And so 2k equals 7. K equals 7 over 2. Or we have k plus 5 equals 0. K equals negative 5. So we have two k values, and which one do we need? Let's go back. They tell you in the beginning here, k is a positive constant. So that's the key information here. So let's go back. So we conclude k equals 7 over 2, since k is a positive constant. So that is the answer. So here we go. That's the answer. Let's move on to question number 3. So we've been given, let's see, So figure 1 shows a sketch of part of curve with equation y equals log base 10x. The region R shown shaded in figure 1 is bounded by a curve, and the line equation x equals 2, 2 and 14. Using the trapezium rule with 4 strips of equal width, show that the area of R is approximately 10.10. Okay, so how do we work out the area? How do we work out the area of using the trapezium rule? So the trapezium rule, if you do not remember, so we need to know what the height is, obviously, which is b minus a over how many strips we have, and then using that we usually do so a b, right, our y dx, that's like approximately we have h over 2, and then we have the first y value plus 2 times whatever is inside, right? So that could be 1, 2, y2 and goes on, plus the last value, and that's it. Okay, so let's see what we can compute from here. So a, so let's first work out the height. So height is, so how many, so we have b minus a, which the limits are 14 minus 2 over how many widths, how many shaded triangles they said 4 equal strips. So our n is 4, so that's 12 over 4, which is 3. Okay, so that's 3. Okay, so what do you do from here? So what do you do? So we had what? So we had 3 each. So 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11, and then we have 14. Okay, so let's draw a graph. So we have x and y, we have 2, we have 5, 8, 11, and 14. And what are the corresponding values? The y, what do you know about y? Y is log base 10x. Just as a reminder, let's just write it here. So y equals log base 10 of x. And that's what we're inputting into, that's why we have this column here. Okay, so log base 10 of 2, this gives us 0.301. Log base 10 of 5, this gives us 0.699. Log base 10 of 8, this gives us 0.903. Log base 10 of 11, this gives us 1.041. And log base 10 of 14 gives us 1.146. Okay, so now we know that. Let's work out the area, right? The area of R. So we can go ahead and so the formula was what? H over 2, right? H over 2. So let's do that. So H over 2 is what? So 3 over 2. So what's the initial value? Which is the y0, which is this one, right? This is our y0, y1, y2, y3, and this would be our y4 or our y and the last value. Okay, so those are the corresponding values from this. See, from here. Okay, so the first value is, so we have what? 0.301 plus 2 times. So what's inside? 0.699 plus 0.903 plus 1.041 plus 1.146. That is what we're going for. Okay, so let's see. So when you put this calculator, so 3 over 2 multiplied by 0.301 plus 2 multiplied by 0.699 plus 0.903 plus 1.041 plus 1.146. This gives us, so now we put the exact value, so we get 10.0995. And when we round it, because they want to round it to 10.10, so this is rounded to 10.10. So that is how we reach this answer. Okay, so what's the next part? Part B says, explain how the trapezium rule could be used to obtain a more accurate estimate for the area. So if you imagine this, right, if we have our, so these are our original, let me just draw a line. Then we have our 4 equal strips. So these will be our 4 equal strips. I've not drawn them properly, but basically these are rectangles. These are rectangles, right? These are rectangles, and this is also a rectangle. And this goes on to, I'd say, here, and this is also a rectangle. And from here as well, also a rectangle. Okay, now if we were to use more trapeziums, right? So let's say we use more trapeziums, we would get a much more accurate result, right? If we were to use, let's say, you can see over here, we have very small gaps. Let's just keep on going. You get the idea, right? So you see that if you use smaller strips, less of this area is accounted for, so it's more accurate. So what do we need to use? We need to use more strips, right? So part B, to get a more accurate result, just use more strips. So use their wording. Use more strips of equal width. Use their wording. So you know you're fine. Use more strips of equal width. All right, that is the answer for B. It's only 1 mark, so that makes sense. So now we have C part I. Using the answer to part A, making your method clear, estimate the value of, so we're given the same limits, so that's fine, 14 and 2, log base 10 of root x. Now we need to do a little bit of rearranging. Now log base 10 of x can be written as x to the power of half, right? And using the power rule, we know that half can come over here. So this would become half log base 10 of x. And we just worked out log base 10 of x. We just worked out it, right, on part A. So we can just take it out. So this is equivalent to, so I is equivalent to what? So let's go down and write it. So I, so 214 of log base 10 of x square root is equivalent to what? 214 of log base 10 of x to the power of half, and then it's equivalent to 214, half goes here, log base 10 of x, and then we can take it out. So half is just a constant, so we can take this out over here. So this becomes a half 214 log base 10 of x. And we know what this is, right? We know what the value of this is. This is 10.10, right? So the answer would be a half times 10.10, which is 5.05. So that is the answer for part I. Let's go to part I and I, part II. So we have log base 10 and then 100x cubed. So let's simplify this. Let's just make everything simple. So we'll do it here this time. So we have same thing, same limits. Log base 10, 100x cubed. Okay, so let's break it down. So we have log base 10, and we can now, let's rewrite 10 as 10 squared multiplied by x cubed. Now, what do we know when we multiply something in logs, when it's inside this, in the brackets? The multiplying them is equivalent to adding logs, right? So now, let's build them up. So log base 10, 10 squared plus log base 10 x cubed. Now we know that the power comes down, the power can come down. So this is now equivalent to 2 log base 10 of 10 plus 3 log base 10 x. Now, what do you know about log of a, base a and a? This is what? Equivalent to 1. Similarly, this is now equivalent to 1. So this will be just 2 times 1, which is just 1, plus 3 log of x, right? So now we can write our 14, 2 is equivalent to 2 plus 3 log 10x dx. Okay, we can work this out. So we can now split it up. So 14, 2 limits. So this would just be 2 dx plus what? We can take the 3 out of 2, 14 log base 10 x dx. Now we know this is what? This is 10.10, right? So we can work this out. So we're left with just 2. This is what? This is 2x with the limits 14 and 2 plus 3 times 10.10. We can work this out. So this would be what? So this would be 2 times 14, which is 28, minus 2 times 2, which is 4, plus this would be 30.30. This would just be 28 minus 4 plus 30 points. So 20 minus 24 plus 30 was just 54.30. That is the final answer. All right, let's move on to question number 4. So we have f of x is x squared minus 2, 2x minus 3 minus 21. State the value of the remainder when f of x is divided by 2x minus 3. So when a function is divided by something, we can just put f of, so 2x minus 3 equals 0, right? So x equals 3 over 2. So we can just substitute 3 over 2 here. Now what is so special about 3 over 2? We can see it's over here already, right? So that means when you substitute 3 over 2, this should give us 0. And if that gives us 0, so f of x would just be left with minus 21. So the remainder would be what? Remainder is just minus 21 equals minus 20, not 121, just 21. So that is the answer for part A. Alright, so now let's go on to part B. Part B says what? Use the factor theorem to show that x minus 3 is a factor of f of x. So to show that, what do we have to do? We have to do what? Do f of 3. Okay, so what is the function? So we have 3 squared minus 2. Then it's 2 times 3 minus 3. And the whole thing, take away 21. Okay, so 9 minus 2 is 7. 2 times 3 is 6, minus 3 is 3, minus 21. That is 21 minus 21. That gives us 0. And what can we conclude? So we have to state, so since there's no remainder, that means it's a factor. So x minus 3 must, you have to say, must be a factor. Must be a factor of f of x. Right, so here we go. Must be a factor. All right. What about part C? Hence, factorize f of x. Okay, so when they say hence, that means that we have to use the information given to us to factorize it. And then it says show that the equation f of x only has one real root. When we talk about roots, always think of discriminant. Discriminant, which is b squared minus 4ac. Now let's factorize this. How do we factorize it? First, let's expand the brackets. So we have part C, I over here. So let's expand it. So f of x equals, so we have x squared minus 2, right? 2x minus 3 minus 21. Let's expand. So that would be what? So over here, 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 and here. So x squared times 2x is 2x cubed, and then minus 3x squared minus 4x plus 6 minus 21. Okay, so this can be simplified to 2x cubed minus 3x squared minus 4x, so 6 minus 21 is minus 15. Now we know that it must be a factor, so the only thing we can do to factorize, right, is to do long division. So x minus 3, that is there any other way we can solve this question apart from using x minus 3? I don't think so. So this would be, so let's just write, so long division, 3x squared minus 4x minus 15. All right, so now what? So how do we expand this? How do we divide? How do you do the long division? So we want a number that gives us 2x cubed here. So this would be when you multiply, so that would be what? That would be 2x squared. So when you multiply 2x squared by x minus 3, this gives us what? This gives us 2x cubed minus 3 times 2, which is just minus 6x squared. So then what? We take away, and what are we left with? So we're left with minus 3 minus minus 6, which is plus 6. So minus 3 plus 6 is just 3x squared minus 4x. So how do we get 3x when we multiply it here? How do we get 3x? 3x squared. We have to do plus 3x. So when you plus 3x, what do we get? Plus, so 3x squared, right? 3x squared minus 9x. Yes? Now we subtract everything. So 3 take away 3 is 0. So minus 4 plus 9, that's going to be plus 5x, right? Do another color. So 5x plus 15. How do we get 5x plus 15? Sorry, minus 15, not plus 15. So minus 15 here. This just drops down, obviously. And so how do we get this 5x minus 15? Obviously, we just multiply by 5. So we get 5x minus 15 equals 0. So when you take away, obviously, the same thing, same terms. So when you subtract them, we get 0. So that means f of x can be factorized as, x minus 3, 2x squared plus 3x plus 5. Okay. Can we factorize this any further into anything? Can we factorize? Because the answer was, question was, can we factorize? Okay. So when you put this in calculator, we will actually get an imaginary number. So it's actually not solvable. But let's say we wanted to solve it. How can we check? This is where the other part comes into play, where it says, show that f of x equals 0 only has one real root. Okay, so now let's go to part II to see whether we can factorize. So f of x equals 0, right? That means what? X minus 3, and so 2x squared plus 3x plus 5 equals 0. So what are the real roots? Either this is the real root, obviously, x minus 3, this gives us 3. So that must mean this is not a real root. So how do we check whether this has a real root or not? We do a discriminant over here. So we do b squared minus 4ac on what equation? On this equation. So what's the b? It's 3 squared minus 4 times 2 times by 5. Okay, so that's 9 minus, so 4 times 2 is 8, times 5 is 40. So 9 minus 40 is what? What's 9 minus 40? Which is minus 31. And this is less than 0. So what does that mean? This is a not real root. So have we answered the previous question, which was, can we factorize it? We cannot. So we just leave it as it is. So this is the answer to the previous question. And what about the part II? They ask us, it only has one real root. We proved it. So it's not a real root. So only real root is x minus 3. which is x equals 3 is our only real root. So we proved it. All right. And how was the proof? We used b squared minus 4ac. Let's move on to question number 5. So we have a company that owned a silver mine, extracted 480 tons of silver in year 1, 465 in year 2, 450 tons in year 3, and so on, forming an arithmetic sequence. Find the mass of silver extracted in the year 14. Okay, so from this is the first year. So what can we state? There's a couple of things we should state. This is the first term, right? So A is what? It's 480, right? Okay, what do we know about an arithmetic sequence? What's the generic formula of a nth term? So un is what? A plus n minus 1 d. So to remember this, I'm just going to box it. That is the formula of an arithmetic sequence. So we know what A is. Okay, so that's done. And we know what A is. What can we do about D? What can we gather from this? So it goes from 480 to 465. So what's the difference? It is 15. So it goes from negative 15 once, and does it go again negative 15? 65 minus 50 is also 15. So it also goes down by 15. So what can we say? D is also, so the common difference is negative 15. And they want year 14. So they want the 14th term. So it's going to be A plus, so n minus 1, which is 13d. Okay, so how do we find the 14th term? So that would be, so A plus 13d. So this would be 480 plus 13 multiplied by negative 15. And this gives us 285. So mass of silver in year 14 is 285 and tons, right? Tons. Right. So that's that. What about part B? After a total of 7,770 tons of silver were extracted, the company stops mining. Given that this occurred at the end of year n, show that n squared minus 65n plus 1036 equals 0. So what are we supposed to do here? The key word here is actually total. Now, we have a formula for what? The total of an arithmetic sequence, which is what? Which is Sn equals what? N over 2, 2a plus n minus 1 multiplied by d. Alright, so now we can just substitute it. So part B, and instead of using normal n, we can use capital N. So that would be what? That would be n over 2. 2 times what? What's our A? 480 plus capital N minus 1 multiplied by negative 15 equals what? 7,770. Okay. Let's move on to 2. Let's multiply everything by 2. So we'll get N. Right? Now what? Let's simplify here. So that'll be 960. Right? So now multiply everything in the inside. So let's figure this out. So that would be minus 15n plus 15 equals, so this multiplied by 2 is what? 15,540. Okay, now let's simplify. So n, so this is now 9, is it 960? It is 9 what? 60 plus 15 is 975. Okay, 975 minus 15n equals 15,540. And now let's expand. So this would be 975n minus 15n squared equals 15,540. Let's move on everything to the other side. So 0 equals 15n squared minus 975n plus 15,540. Okay, so now they want n squared, so we can just divide everything by 15. So 0 equals n squared minus, so 975 divided by 15 is also minus 65 plus, so when you divide 15,540 by 15, we can confirm we get 1,036. So how did we get here? We used the total formula, substituted it, equated it to the total 7,770, and then we reached our equation over here. Okay, hence state the value of n. So we just have to factorize this. Okay, so b, so what I usually do is I remember that I can either use the quadratic formula, or I can just use the calculator and then work backwards. So when you use the calculator and work backwards, we get the values n equals 28 and n equals 37. Okay, so that means that the factors are n minus 28 and n minus 37, which equals 0. And then we can just write the original equation, n squared minus 65 plus 1,036. Now it looks like you've just factorized it, right? Which is what we want them to know, right? So what value are we supposed to take from 28 to 37? Now let's think of it practically. They said that after a total of 770 tons, the company stopped mining. So that means the company stopped mining after 28 years, right? Or they stopped mining at 37 years. Now, if it stopped at 37 years, so why did it stop before 28? That means that it only stopped here, the earlier year, which is 28 years, and then that's it. The 37 we don't care about because it's later. We only care about when it stopped mining. So the year is 28. So n equals 28. All right, so that is part C done. Let's move on to question number 6. So they tell us that the circle C1 has equation x squared plus y squared plus 10x minus 12y equals k, where k is a constant. Find the coordinates of the center C1. Okay, we have to do what? We have to complete the square to get rid of these x squared values. So part A, let's complete the square. So we have x squared plus 10x, so that will be what? We take half of it, so x plus 5 squared, right? Minus 5 squared, obviously. What about the y? The y, we know y squared has minus 12y, so we divide it, so that will be plus y minus 6 squared minus 6 squared. And this equals what? This equals our k. So what's the center? The center is minus 5 and 6. We take the opposite of what inside. So that is the center. Okay, so now what? Part B, state the possible range of values for k. So now let's move everything across to the other side. So this will give us x plus 5 whole squared plus y minus 6 whole squared equals k plus 5 squared plus 6 squared. So what is it? So it's k plus, so 5 squared is 25 plus 36. So k plus 61 is our r squared, right? This is our r squared. Now what do we know about squared values? That r squared has to be greater than 0, right? So k plus 61 has to be greater than 0, so k must be greater than minus 61. So let's just repeat of how I got here. So we had the original equation over here, right? And then we completed the square. I moved the 5 squared and the 6 squared across to here, right? See over here, moved it across on this left right hand side, and I know that this is equivalent to our r squared, our radius squared, and I know that r squared has to be greater than 0, right? Because the radius has to be greater than 0. So what does that mean? That means that k plus 61 has to be greater than 0. So now we have the range, so k must be greater than minus 61. So that's how I got here. Let's go to part B, sorry, II, just II. Didn't know that, so that's just IA and then IB. Now we have II. We have the point P0, the point Q minus 210, and the point R lie on a different circle C2. Okay. Given that P is a positive constant and QR is the diameter of C2, what can we do here? Okay, so we know that, what do we know? We have another circle, and they all lie in this circle C2. Okay, so we know that QR is the diameter, right? So if we have Q and we have R, we have the diameter here. That means its midpoint must be the center, right? The midpoint. Okay, so if we know that's the midpoint, okay, how did that help us? Because we know if we can then find out what? The equation of the circle, and then what? That equation will help us find P, because we can substitute it into this equation that we will have to find, right? So let's do that. Okay, so that would be what? So how do we do that? So first we need to find what? The distance. So we need to find distance of QR. And how do we do that? We have the two coordinates. That would just be square root of what? Just the difference between the two, right? So minus 2 minus 8. So minus 2 minus 8 whole squared plus 10 minus 14. So 10 minus 14 whole squared, right? This is what? This is equivalent to, so that's 10 squared, that's 100. That is 24 squared, that is 576. Okay, so when you square root it, that's square root of 676. And that actually is a whole number 26. So the distance is, so this whole distance is what? It's 26. So this must be 13. Right? We know that it's 13, right? Okay. So what about the center? We can easily find the center, can't we? We can easily find the center. The center is what? Just the midpoint. So midpoint is what? We just add the coordinates, right? So let's just write Q here so we remember. So Q is minus 2 and 10. And R is what? R is 8 and negative 14. Okay, so we just have to add them, right? So midpoint is minus 2 plus 8 over 2 and 10 minus 14 over 2. That is the center. That this gives us 6 over 2, which is 3, and this is 10 minus 14, which is 4, over 2 is minus 2. Okay, so now we can do what? We can do what? We know r is 13. We can do what? Because this is divided by 2. We can find the equation of circle. So what do we know? So we know that it's usually x minus, so that will be 3 squared, plus y minus 2, so that will be plus 2 whole squared, equals r squared. Now what is r squared? It is 13 squared, which is 169. So 169. Now we can substitute our p and 0 to find what p is. So that would be easy. P minus 3 whole squared plus 0 plus 2 squared equals 169. So p minus 3 whole squared plus, so what's 2 squared? Which that's 4, equals 169. So p minus 3 whole squared is equal to 165. All right. Okay, that's good. And then p minus 3 equals square root of 165 plus or minus. Don't forget that. So p equals 3 plus or minus root of 165. Okay. Are we done? Is this it? Is this a final answer? It's not, because they tell you that p is a positive constant. So now we can use that information to say p equals 3 plus root 165 since p is a positive constant. Okay, so how did we get here? So what we did was, we knew that all these points lie on circle 2, right? Lie on circle 2. And then we know that because it lies on circle 2, we can just substitute these two coordinates into the equation of a circle to find p. But in order to do that, we had to find the center, which we did, right? And the radius, which we also did, which is 13. And that helps us find what p is by substituting into this equation. Well, into this equation. Okay, let's move on to question number 7. So that is here. So now we have a geometric sequence. So question number 7. A geometric sequence has the first term 4 and the common ratio 6. Given that the nth term is greater than 10 to the power of 100, find the minimum possible values of n. Okay, so a mouthful. So they tell you a equals 4 and r equals 6. Common ratio is r. Then, so let's just write it down. So this is part I. This is part I. Let's write it down. So a equals 4 and r equals 6. And we know that the nth term is what? ar to the power of n minus 1. That's just something we need to just know. Right? This might help us. This is not given to us, but this will help us. Then the nth term is greater than 10 to the power of 100. Okay, so they're saying that un, which is 4 times 6 to the power n minus 1, is greater than 10 to the power of 100. So how do we get this n? How do we get that n? So we have to do what? We have to log both sides, right? So let's log both sides. So log 4 times 6n minus 1 log what? This is also base 10, by the way. Log base 10 100. By default, it's 10. When you put in the calculator, log is just 10. Base is always 10, but you can also change it yourself. Okay, so now, so that'll be what? When we multiply logs, that's the same thing as adding. So log base 10 of 4 plus log base 10 4, 6 to the power of n minus 1, right? Greater than 100 log base 10 of 10, right? So this is obviously just equivalent to 1. So then it's just what? So log base 10 of 4. Then we put it back down. So plus n minus 1 log base 10 of 6 is greater than 100. So we just want what n is. So let's expand. So that would be, so we can take this and put it on this side as well. So we're left with n log base 10 of 6, right? Minus log base 10 of 6. That looks like a 16th. 10 of 6 is greater than 100 plus log base 10 of 4. So now, so n log base 10 of 6. We're just rearranging to find what n is. So this is just 100 plus log base 10 4 plus log base 10 of 6. So at the end, n is greater than. So I'm just going to copy this. Copy, paste. And this is greater than, obviously, greater than log base 10 of 6. So let's put this in calculator. So this is 100 plus log base 10 4 plus log base 10 6, and then over log base 10 6. So n is greater than 128.7. So we round it, so n equals 129. So it's all working out, but it's necessary working out. Maybe not repeating them all together. You can just do maybe these this step and this step in one go if you want to, but there are necessary steps to understand what's going on. So that was part I, even though it's 3 marks. So we get n. So yeah, we highlighted it. So the next part, a different geometric sequence has the first term a and common ratio r. Okay, so the second term of the sequence is minus 6. The sum to infinity of series is 25. So let's just write it here. So we know that that the first is just a, right? So u2 is what? AR. So we know that AR is equal to minus 6, and sum to infinity is what? A over 1 minus r is equal to 25. So let's just use that. So we have our I, and that is part A. So U2 is AR, right, which is equal to what? Equal to what? Minus 6. And sum to infinity is what? It is A over 1 minus r, which is 25, right? So AR equals negative 6. You can see there's a over here and there is no a, and what show that this equation, there is no a here, so we can just make a the subject. So a equals minus 6 over r here, and a equals 25. So multiply by 1 minus 25 r. So we can just substitute them all together. Equate them. 25r equals minus 6 over r. So multiply by r, so 25r minus 25r squared equals negative 6. Move everything to the other side, so 0 equals 25r squared minus 25r minus 6. And is that what they want? That is what they want. Alright, so we got there. And part B says, so write down the solutions of 25r squared minus 25r minus 6. Okay, it's actually pretty straightforward. You can see there's 25 here, so clearly, so part B, we're doing 5r something and then 5r something. And because they're both negative, you can see that 5r minus 6 will give us minus 30r, plus 1 5r will give us, plus 1 times 5r will give us minus 25. So those are our two r values. So let's work them out. Equals 0 and 5r minus 6 equals 0. R equals negative 1 over 5 and r equals 6 over 5. So which one are we supposed to use? 6 over 5 or minus 1 over 5? Now, to help us, we need to remember that the modulus of r needs to be less than 1. So that is the key thing we need to remember in geometric series. So that means that we don't consider 6 over 5 because it's greater than 1. So r equals 1 over 5 because of that. So r equals 1 over 5. And I'm just going to write since less than 1. So I'm just going to include that in the solution as well, because the reasoning is important as much as the answer. Okay, so part C. Oh, we just did it. Write solutions. Health state. Oh, we just did that. State the value of r, giving a reason for your answer. We just did. So that's B. So that's B. That's C. Sorry, that's our C. So we did that as well. Okay, so the values they want is 1 over 5 and 6 over 5. Okay, let's move on to part D then. Part D says, find the sum of the first 4 terms of the series. It's like pretty easy. So we can just do that. So we know that, so part D, we know that, what do we know? We know that r equals 1 over 5 minus 1 over 5. And AR equals minus 6. So we can just find what A is. A equals minus 6 over minus 1 over 5. So that is 6 times 5, which is 30. Okay. Now to find out the sum of something, sum of the formula, which is what? A1 minus r to the power n over 1 minus r. Gonna box it. So this is what we're gonna use. So let's substitute it. So S of 4, the first 4 terms, so that'll be A is 30 multiplied by 1 minus r. R is minus 1 over 5 to the power of 4. Take away. So all over 1 minus 1 over 5. So this gives us, so when you put this in the calculator, this gives us S to the power of S, sum of 4 terms is 6 to 4 over 25. You can just leave it as this or the decimal form. They both are correct. Wait, both are correct. Okay, is that it? That is it. Okay, let's move on to question number 8. Let's move on to question number 8. So the question number 8 is here. I think I just missed it. No, that's 9. Question number 8. They tell you in the question you must show all stages of your working. So that's clear. Solution relying on all calculator are not acceptable. So just don't use the calculator fully. Or if you do, show the working out at least. Figure 2 shows a sketch of a part of a curve. So this is the curve. Okay, plus kx. We don't know what k is. The point M is the maximum turning point of C, which is here. Okay, and this touches another line L. Okay, so given that the x coordinate of M is 2, show that k equals 28. Now this doesn't help us in any way. Does this help us in any way, shape, or form? How do we show that k equals 28? So we know that this is M is a turning point, right? This is a turning point. So that means that gradient must equal 0 at the turning point, at M basically. And we know that the x coordinate of M is 2. So what if we just differentiate? So let's try differentiating. So we have A So let's try dy over dx, right? So what do we have here? We have 4 over 3x cubed. We multiply by 3, we will get 4x squared minus, so 11x squared becomes 22x, and then kx just gives us plus k. Okay, so this equals 0, squared minus 22x plus k equals 0 when x equals 2. So let's just substitute it. So that would be 4 times 2 squared minus 22 times 2 plus k equals 0. So 2 squared is what? 2 squared is 4. 4 times 4 is 16. Minus 22 times 2 is 44. Plus k equals 0. So this gives us k minus 28 equals 0. So k does equal 28. So that is how we get k equals 28. How do we get here? We differentiated because we know that point M is the maximum turning point here. We can see that. So and they gave us this information to use the information. So we use that information to differentiate equal to 0 when x equals 2 to get our k equals 28. Let's go to part B. Determine the range of values for which y is increasing. So how do we determine whether a function is increasing or decreasing? We have to look at what? We have to look at the dy over dx. We have to look at that, right? We have to look at that. So let's look at that. So dy over dx, so part B. So now we know it's what? It's 4x squared from the previous questions. 4x squared minus 22x plus 28, right? And we need to check whether it's increasing. How can we check whether it's increasing? We can only check it whether if dy over dx is greater than 0, then we can say the function is increasing. But we need to show that. So that means 4x squared minus 22x plus 28 is greater than 0. Let's divide by 2 here to get what? To get 2x squared minus 11x plus 14 greater than 0. Can we just solve this? No, we have to convert this into an equation. So 2x squared minus 11x plus 14 equals 0. So now we can get the critical values. So this would be 2x, then x equals 0. So we need to find two numbers. So this would be, because it's plus, this will be negative 2. That looks really wonky. Minus 7 here. Okay. So based on that, what can we do? We can find that x is equal to 7 over 2 and x equals 2. These are our critical values, right? Critical values. Okay, so what can we do from here? We know that this is this, so now we can go back here and we can state that the bigger, what can we say? We need to state a range, right? We need to state range. And because it's greater than 0, we have to state that x is greater than 2 and x is less than 7 over 2. So that's the range. So this is the answer here, for which y, our dy by dx is greater than or is increasing. That's what they want, increasing. Okay, so we did that. Let's move on to part C. The line L passes through M. Okay, we know what M is. It has an x coordinate of 2 and is parallel to the x-axis. Okay. The region R shown in the figure 2 is bounded by the curve C. Okay, and the line L on the y-axis. Find by algebraic integration of the exact area of L of R. So we know this is 2. Okay. This goes on all the way here. How do you work out this area R? Now, if you remember, to work out this area, we have to do line, so the equation of line minus the equation of the curve at the limit. So limit is 0 and 2 dx. So do we know the line of this curve? Do we know the equation of this line L? We don't. So we have to figure that out. And because we know this is a straight line, and if we can just find the y coordinate of M, that would be equal to the equation, right? That'll be equal to it, because this is a straight line parallel to the x-axis. So let's do that. So let's go over here. So this is part C now. Part C. So this is what? So we know that y equals what? So y equals 4 over 3x cubed minus 11x squared plus kx. We have to substitute 2. So 4 over 3, 2 cubed minus 11, 2 squared plus 28. So when you substitute this, we will get 28x, so multiply by 2 here as well. We will get 68 over 3. So the line L is what? Is y equals 68 over 3, right? So now we can work out the area of R would be, so the limit 0 and 2. So line minus curve, so 68 over 3 minus, what's the curve? The curve is 4 over 3 x cubed minus 11 x squared plus 28x dx. Let's simplify this. So this would be what? This would be just 2 and 0. 68 over 3. That doesn't look like a 68 over 3 minus 4 over 3 x cubed minus 11x squared plus 28x. Oh wait, no, not negative. That will be plus, and that will be minus. So minus 28x dx. Okay, so now we can just integrate it. So this will just be 68 over 3x. This would just be, so plus 1 divided by 1. So this will be, so plus 1 divided by 1. That would be x to the power 4 over 4. Or is it x to the power, wait, is it? No, x to the power 4 over 3. Let's just do 4 over 3 multiplied by x to the power 4 over 4, and we can simplify later. Plus 11x cubed over 3 minus 28x squared over 2. 2 and 0. Let's now simplify. This is now 68 over 3x. So 4 and 4 will cancel. So minus x to the power 4 over 3. Okay. Plus 11x cubed over 3. Right? And so this would be minus 14x squared. 2 and 0. Now we just now substitute. That will be 68 over 3 times 2 minus 2 to the power 4 over 3 plus 11 to the power 3 over 3 minus 14 2 squared, and take away 0 because it's just 0. Okay, so let's put in the calculator. So 68 over 3 times 2 minus 2 to the power 4 over 3 plus 11 times 2 to the power 3 over 3 minus 14 times 2 squared is equal to 40 over 3. So area of R equals 40 over 3 units squared. That is the answer. Let's move on to question number 9. Alright, so now we're at question number 9. So prove for all values, all positive values of x and y, that x plus y over 2 is greater than or equal to square root of x plus xy. Okay. So the key to this is to work backwards. So I'm going to show you what you can do and then work backwards. So now let's expand. Let's just see how we get. Let's expand. So let's bring the square root on the other side. So you will get x plus y whole squared over 4, right? 2 squared is 4. Is greater than or equal to xy, right? Let's expand everything. So that will be, so x squared plus 2xy plus y squared is greater than or equal to 4xy. Okay, so now what? Then x squared, so take away, so minus 2 minus 4 is minus 2xy plus y squared is greater than or equal to 0. Now can we factorize this? Yes, we can, and actually we will get x minus y whole squared is actually greater or equal to 0. Okay, so this is what we gained from just working backwards. We just start to see where this would lead us. But is this what we write in the paper? No, we don't write this. We write what we write in black. So consider, because we want to reach here. So basically, we want to start off with something and then we want to reach here. We want to reach here at this step. In order for us to do that, we work backwards to see where we start off from. So we start from here. Okay, so consider, so we write x minus y whole squared is greater than or equal to 0, right? And then we expand, right? We get what? X squared minus 2xy plus y squared is greater than or equal to 0, right? We move the 2xy to the other side, so x squared plus y squared is greater than or equal to 2xy. Then what? Because we want this on its own and we want x plus y, right? You can see over here we want x plus y. So we just do x plus y whole squared minus 2xy, right? Because the same thing as x squared plus y squared greater than or equal to 2xy. And then this becomes x plus y whole squared is greater than or equal to 4xy. When we square root it, so we get x plus y, well, not like that, square root 4xy. This gives us x plus y greater than or equal to 2 root xy, and then we get x plus y all over 2 greater than or equal to root xy. So that's how, this is what we actually write. So we write what we wrote in black. This is working out, so we know what to write. Okay, so this is how we get to the answer. Let's move to part B. Part B says, prove by counterexample that this inequality does not hold when x and y are both negative. So let's just take any value. Let's take any value. And obviously we have to state that at this step, right? At this step, that we have to state that x, y, both positive, or else, the sign changes, so both positive. Because we can't square root a negative in negative. We can't square root this, so it won't work if it's negative. All right. So part B says, let's just use any two negative values. So let's say x equals -3 and y equals -5, right? So this should work in theory. So -3 plus -5 over 2 should be greater than root of, what is it, xy, which is -3 times -5. So -3 minus 5 is -8 over 2 is -4. And this is what? This is root of 15. Now this is what? This is the other way, right? So not true. So not true. And we just leave it at that. This is our counterexample. So that's question 9 done. Let's move on to question number 10. Okay, so we have In this question, you must show all stages of working out. All stages of working out, solution relying entirely on calculator technology are not acceptable. So solve for minus pi over 2 x pi over 2. So tan squared 2x plus pi over 4 equals 3. So where do we go from here? First, we change the limits, the range, sorry. So we add the 2x, so this would be minus pi greater than 2x, which is less than pi over just pi. Then we add the pi over 4, so this becomes minus 3 pi over 4 2x plus pi over 4, which is less than. So this would be 5 pi over 4. Okay, so now we can solve this equation. So we get tan, so we square root both sides. So 2x plus pi over 4 equals square root of 3. Then we know that 2x plus pi over 4 is equal to tan inverse of root 3. So what do you get when we tan inverse? And remember, this must be in radians, obviously. Radians. Don't forget that, obviously. Radians for this part I in the calculator. So when tan inverse this, what do we get? We get pi over 3, right? We get pi over 3. Now, is this the only solution? If we were to draw the cast diagram, so CAST, right? Pi over 3 is what? Is 180 divided by 3, which is 60 degrees, right? So this is around about here. No, it's around about here. That's the first solution. Then we keep on going. We get the second solution. We keep on going until we are here at 5 pi over 4, just below it. So this is 2 pi or 0. This is what? This is what? This is pi over 2. This is pi. This is what? This is 3 pi over 2. All right. So let's see what the solutions are. And also we can have to go backwards as well, because you see the negative sign. So we can also go the negative direction. We can also go here and then here as well. Okay, so let's see how that looks like in writing. So pi over 3. So we added the pi over 3. We add what? We add what? Can we add our pi? We can't, because then it will be greater than pi. Pi over 2. So get rid of that. So we know that. Then we can take away, right? So this will be what? Pi minus pi over 3. And then what? Minus pi. So we're going this direction now. Minus pi plus pi over 3. And then we just have the normal, just going backwards, minus. So there'll be minus 60 degrees, which is minus pi over 3. Okay, so those are our 4 values, right? But are we done here? No, we're not. So 2x plus pi over 4, or actually, it is 2x. We can take away the pi over 4 now. So this will be pi over 3 minus pi over 4. So pi minus pi over 3, take away pi over 4, minus pi plus pi over 3, minus pi over 4, minus pi over 3, minus pi over 4. So 2x equals, so let's simplify. So this is what? So this is pi over 12, 5 pi over 12. This is negative 7 pi over 12. And this is minus 11 pi over 12. Are we done? No. X equals, so the final answer, pi over 24. And 5 pi over 24 minus 7 pi over 24 minus 11 pi over 24. That's our final answer for this. All right. Let's go on. Let's look at this. So solve for theta greater than 0 less than 360, 2 sine theta minus cos theta whole squared equals 1. So let's do that. So let's just do it here. So we have part II. We have 2 sine theta minus cos theta whole squared equals 1. Pretty straightforward. Let's expand. So this would be what? This would be same thing as saying 2 sine theta minus cos theta multiplied by 2 sine theta minus cos theta. So let's multiply them. We will get 4 sine squared theta, right? Minus 2 sine theta cos theta, and another one. So that'll be minus 4 sine theta cos theta plus cos squared theta equals 1. Okay. So we need to just solve it. So let's see. So what can we do here? Can we manipulate anything? Can we change anything? Yeah, we can change the 1, right? The 1 we can say is what? We know that cos squared theta plus sine squared theta equals 1. So let's do that. So that'll be what? Be 4 sine squared theta minus 4 sine theta cos theta plus cos squared theta equals cos squared theta plus sine squared theta. Then you can see here the cos squared cancel with the cos squared and sine squared, and this becomes a 3. So we're left with 3 sine squared theta minus 4 sine theta cos theta equals 0. What do you do now? Is there anything common? Yes, we can divide by sine, or actually take sine as a common. Sine theta equals 3 minus 4 cos theta, right? Well, not 3 sine theta, it's actually 3 sine theta. 3 sine theta minus 4 cos theta equals 0. So we got our two things. So we know either sine theta equals 0, or we have 3 sine theta minus 4 cos theta equals 0. So we have 3 sine theta equals 4 cos theta. Now we can divide, we can move the cos to the other side, and this becomes a tan. So this, and move the 3 on the other side, this becomes sine theta over cos theta equals 4 over 3. So this becomes tan theta equals 4 over 3. Let's look back. What else can we do here? We need to know what theta is now, right? Now if we look at the cos diagram, right, when does it equal 0? So it's either CAST, right? It's either when it's in 0 or 180 or back to 360. So out of these, which do we care about? What do we care about? 0, 180, 360. What do we care about? We don't care. So let's look at the range. It does not say greater than or equal to, so we don't care about 0, we don't care about 360. So this is the only thing we care about, 180. So from here, so from the left hand side, so theta equals 180 is the only thing we know so far. Let's go back to our tan. So theta equals tan inverse 4 over 3. So this gives us 53.1 degrees. So let's just draw our cast diagram, CAST. So we have our 53.1 degrees. Over here, we add another 180 degrees over here. So plus 180 because it's positive. So that would be, so add 180, we will get 50. We get what? We get 233.1. Do we continue all the way here, all the way back here? No, because it's greater than 360. So our values for theta is 53.1 degrees, 233.1 degrees, and 180 degrees. Let's look back. Did they talk about degree of accuracy? To 1 decimal place, and that is to 1 decimal place where required. Okay, that's the end of the video. Please like, share, subscribe, and join the Discord where you can talk to me personally and you can talk to other people doing the same things as you and other subjects. Until next time, I will see you guys later.